Hello, good afternoon, good morning, everybody, and welcome to this Telecoms Academy Insight webinar. Subject today, LTE for public safety. My name is Dave McNally. I'm an instructor with the Telecoms Academy, and I'm going to be your presenter for today. Right now, thanks. Let me just flick back to the opening screen here. Now, thanks for answering those questions. I think there's some sort of quite interesting results from that. One of the questions that I was asking there was, what's the best way forward for public safety? And I think that's probably the most important question that we could have at the moment. And it looks like about 70% or so of you are saying that we need a standalone LTE network. And I think the question asked at the bottom of the screen there regarding what your concerns would be if we ended up sharing with commercial LTE networks. There's a lot of information there about a lot of submissions there related to security, capacity, resource management, quality of service, and so on. And clearly these are all valid concerns for how we continue to build and manage our public safety networks as we go forward. So yeah, I appreciate you answering those. I have started now, so I'm hoping that you can all hear me okay. I'll just leave that screen on for a moment or two. Maybe if somebody could just give me a quick indication that the audio is okay. Okay, Paul tells me everything is fine. Okay, so we're going to go back to the main presentation now, and we will make a start. So as I mentioned, we are the Telecoms Academy. Some of you might be familiar with the work that we've done before. We might have even trained some of you in the past, but of course we're a technical and telecoms management training organisation, and we work across quite a broad spectrum of topics. We've got what we refer to as internally the School of Telecoms Management. So perhaps non-technical or less technical training, where we deal with a large range of topics related to the management of telecom networks and so on. Perhaps the subject that we're talking about today, LTE and public safety, probably falls into the category of advanced communication technologies, something that I'm quite closely involved with here at the Telecoms Academy. So anything from sort of basic foundation programs introducing telecommunications to pretty much in-depth engineering type training, so LTE, LTE planning, and of course LTE and public safety. And pretty much everything that we do, whether it's management-based or technology-based, can also be delivered via distance learning programs or even online training, which we tend to do on a slightly shorter basis. Now you've got some contact information here. I'm going to flash this screen up again at the end, so don't worry if you don't catch this right away. I'll put that again up at the end, so you've got some contact information if you want to know more about what we do. Now we're also in partnership with an organisation which I'm pretty sure you've heard of, Ovum Research. A lot of the information, particularly in the telecoms management and in some of the other courses that we do, we pull a lot of information, research information from Ovum. We find it's really useful when we're presenting some of our training courses, just to give the participants of the training materials really just a bit of an insight into what's happening in the world, the various trends that there are in the different sectors within telecoms. So Telecoms Academy and Ovum Research, we really work together as a partnership, and we tend to present a lot of their knowledge within our training programs. Again, I'll put more information up about what we do and who we are and how to contact us really at the end of this session. But we'll get into the presentation now. So of course, LTE for public safety. So by public safety, of course, we're talking about those emergency communication networks that typically the blue light services would use, so the police, the fire brigade, the ambulance services, and other services that would really consider themselves to be part of any emergency action. Of course, there are some criteria, should we say, some specific requirements that public safety systems have. Now, this is really just a sort of a general introduction, should we say, for what the overall requirements of a public safety communication system should be. And the existing systems, which we'll talk about in a moment or two, the existing systems, by and large, will provide most of these to a lesser or greater degree. I mean, for example, things like interoperability. Interoperability clearly is going to be an important thing for our public safety networks. It depends on the country, it depends on the scale of the communications. When you look at perhaps smaller countries like the UK, where we've got one managed system, interoperability shouldn't be such a big problem. But when you go back to, or when you look across the Atlantic there towards the United States, you know, such a vast geographical mass to cover, with many different states, and sometimes those states will have their own independent systems. So, you know, crossing state boundaries and so on, and ensuring that the emergency services can still communicate is a sort of major problem. Any modern communication system should really be seen as being quite spectrally efficient. And when a lot of the services that we might currently be using are based predominantly on voice type communications, we could probably argue that they're already fairly efficient. However, as moving forward, when we start to look at some more advanced services and capabilities, then we still have to be able to meet those modern standards of efficiency that we see with LTE and LTE Advanced and so on. And as some of you mentioned in that sort of those surveys at the start, things like dependability, fault tolerance, because of course we're talking about mission critical communications here, so it's absolutely vital that no important parts of the network will break or fail. We could probably also talk about coverage and capacity and so on as part of that dependability that the network should provide. And I would perhaps suggest that most of the voice-based communication networks that we're using for public safety at the moment are fairly resilient. Maybe where some of the communication services at the moment begins to fall down is when we start considering things like advanced capabilities. And I did a lot of training with TETRA sort of 10 or 15 years ago, and even at that time we were talking about what advanced capabilities these emergency services could benefit from. So there was usually things like live video streaming from an incident, that kind of thing, and we've been having those discussions really for the last 15 years or so. And certainly technologies like TETRA, which are predominantly voice-based, struggle quite a lot to bring a lot of those advanced capabilities. So any new technology that we plan to adopt should really have a serious focus on the data capabilities of these systems. So being able to stream voice and video from multiple points in the network and allow a coherent communication between all of the emergency services that might be involved in any particular incident. Also mentioned in the survey at the front were things like security. Clearly, a lot of the work that the police would do, for example, has to be on the basis of a secure communication. So any hostile party should really not easily be able to attack the system to figure out what might be taking place. And I think because we're probably at this point in time where we're looking at upgrades to the network, we're looking at ways of evolving the network to next generation systems, then I suppose the cost of systems is going to be a big factor in how we might consider these new systems. So there's a great deal of focus on the cost of building these new systems. I mean, largely due to the way that the funding is provided for these things. They're often quite, the most often kind of government-funded projects, and the governments, of course, are accountable for the amount of money that they might be spending on these types of services. I mean, this, of course, is not an exhaustive list of requirements. I just thought I'd pull a few interesting ones out there which might support or support some of the arguments that we might use for different kinds of systems that we need to build. Well, current systems, again, not an exhaustive list here, but the ones which are most popularly deployed, should we say, those which you find in the US and in one or two other places are APCO 25 or P25 based systems, a digital standard, again predominantly providing voice-based services. TETRA may be one of the most widely deployed technologies. Again, pretty much voice-based. It's a European-based standard, and the thing that it does extremely well is group-based voice communications with very limited support for data-type services. Although it has to be said that technologies like TETRA have continued to evolve and now will support some sort of limited kinds of data services in there as well. And when TETRA was being developed, as a decade and a half ago, some competing standards, for example, TETRAPOL, and TETRAPOL again is sort of fairly popular in Europe. Again, is another sort of very efficient voice-based communication standard. I mean, there are others out there, but even though we might, for example, in Europe have a large deployment of TETRA-based systems, just because we're using the same technology doesn't necessarily mean that there will be direct compatibility between different services or different workforces in different locations of Europe. So that idea of having interoperability between different organizations, even though we have chosen the same technology in most cases, that interoperability is not absolutely guaranteed without some additional agreements or contracts being made. So if we're thinking about moving forward with these systems, I mean, the choices that we've got, which we'll discuss in a moment, really means that we may be leaving some of these behind, particularly if we've got to focus on the advanced data capabilities of newer standards like LTE, then it may be that we're going to completely replace these existing standards. So we'll just have a very quick chat about what some of the options might be moving forward, and in fact these are the questions that I asked you right at the start there. So one of the options might be just to continue using these existing systems. So whatever is out there at the moment, I mean, TETRA, for example, we could just continue to use it because it's been in good service for the last 10 or 15 years or so. It works extremely well. It does what it's supposed to do extremely well. But as we mentioned before, some of the limitations of these voice-based systems prevent us from doing the advanced services like video streaming and so on. But I guess there's more to it than just the limitations of the technology, because depending on the arrangement that the organization that runs the network and its users, it's quite likely that there'll be some large-scale renegotiation of contracts and so on with the current providers. And either the contract renegotiation and the upgrades that would be required to the system to support those advanced services would require significant investments over the next 5 years or so. The other option, of course, and I think from the survey that we did on the front page there, seemed to be the most popular. So I think 70% or so of you said that the best way forward is to build a completely new LTE-based network, which would be owned and operated privately by the organizations concerned with public safety. Of course, that clearly seems to be the best thing to do, because I mean, the one thing it allows you to do is have full control over the design process and the operational processes as well. The downside to it, of course, is it's going to be extremely expensive. And in fact, there's been a fair bit of work being done in the UK recently investigating what the next step will be for the current systems we have here. Well, I think the fairly obvious answer is it's an extremely expensive thing to do. I think the estimates run to around about £5 billion to build a brand new system. And of course, once you've decided that this is what you're going to do, and then you have to design the system and choose partners that will assist in the design and build of that process. Excuse me. You've got quite a long deployment time for that as well, because to build a mission critical, fully redundant, highly reliable system, of course, it's not going to be a short-term process to do that. The other option would be to share a commercial network that's already built the system. I mean, LTE has been around for quite a long time now, at least 5 or 6 years in many places. So those commercial operators have got already a 5 or 6 year head start on building the network, building out the radio coverage, building services into the core network, and so on. So those operators may well be in a reasonably good position to provide a basic bearer service or a basic connection service for our public safety applications. But again, that question that I asked on the front page about what would be the concerns about entering into a partnership in this way. So there would surround the availability of capacity, the security of the service, and so on. So the commercial operator would really provide this part. So the core network and the radio access would be predominantly provided by the commercial network. And I suppose one of the interesting things, and I'm going to show you some architectural pictures from LTE a bit later on, that's the external functions required for public safety. So all of the dispatching and the flow control, the group communications, those types of controls could actually be done externally by that public safety body. And really what you're doing is you're hosting your services on that commercial network. I mean, that sort of ignores all of the concerns that we might have about how would that commercial organization prioritize my traffic, my public safety traffic in the network. And at the time where there is an incident which may affect a large population of the public users of that network as well, how would we organize the communications between the essential public safety traffic and those of the public who may be trying to communicate at the same time? And I think a few of you also mentioned things like the requirement for additional coverage in the cases where we may be using commercial networks. Because obviously when a commercial network is planning and building their system, I suppose what they're trying to do is they're trying to put their coverage in the places where they're most likely to make a load of money. So that the commercial objectives of building a network may be very different to those for a public safety system. So this might mean in some cases that where we choose to share or enter into a partnership with a commercial operator, then we'd need to build in additional coverage as required for those locations, those places that public safety users would tend to frequent. So of course the rural areas, deep inside buildings, those places where perhaps a commercial coverage is not currently available. There may be some combination of those things as well, where we could partly build our own network and we could share elements of the commercial network as well. Those would tend to get quite complicated in the detail. But I suppose one thing we can say about LTE is that when it was designed or when it was kind of put together back in the 2000s, it's certainly been designed with this idea of network sharing very much in mind. So whether we're sharing simply only the radio access network, or whether we're sharing the core network facilities as well, and this idea of using some external public safety domain which will control aspects of the commercial operator. All of these things are basically designed into LTE. It does require still quite a bit of work to make it do the things that we want it to do. But I think over the next 5 years or so, both from a standards perspective and from a contractual perspective, we should be able to figure out many of those problems. So, of course, there's activity all over the world in respect of public safety and public safety networks and how we're moving to the next generation of these services. I've just pulled out a couple of examples here. The one which is closest to home for me, at least, is what's happening here in the UK. And the UK government have run this project, the Emergency Services Mobile Communications Programme, ESMCP, really a programme to define and manage the new Emergency Services Network, or the ESN that we're calling it. And just late last year, a lot of decisions were made. I mean, it's a sort of long and tortuous program or project to find out, how exactly we're going to do this. In fact, I mean, what they did is they rejected some of the options that we suggested. They rejected continuing to use the existing airwave TETRA network. They also rejected the idea that we would build a completely brand new standalone LTE network because it's simply too expensive. And in fact, they went with that third option that we specified there, where they will basically use a commercial operator. In the UK, in fact, EE is the winning party in respect of providing the network services for this new emergency services network. Motorola have won the contract to provide the user services and some elements of integration, and Kellogg, Root and Brown as well as the main integrating parties or partners in that process. So there's 3 organizations involved in that. The service is due to begin sort of between July and September 2017, with that really continuing all the way out to 2020. And that's pretty much in line with majority of the TETRA contracts really coming to a close. Now that's very much a UK-centric view. We'd need to spend a bit more time looking at different parts of the world to find out exactly what the overall process or progress is in those. But just as an additional example here, if you were interested, FirstNet, First Responder Network Authority. This, in fact, is it's quite a new thing for the USA. Something created by Congress, really, to create a nationwide public safety network, really based on these commercial standards. There's a lot of information out there about that you can easily find. But this is quite a different thing for the United States, where the individual states themselves were really kind of in charge of their own public safety networks. And that can create interoperability and funding issues. So Congress have basically stepped up now and said, okay, now we're going to have a national public safety network. But as you can imagine, with a place like the United States, trying to organize all of those different states and get everybody to agree on the standard that should be used and the manner in which those contracts should be drawn up, it's very much a political process for the states. So we'd also need to look at Europe and what's happening in the Middle East, the Far East, and so on. To exactly what's happening, but I think the general trend seems to be that LTE is the favored technology for developing these next generation public safety networks. So if there's one thing we can agree upon, then it is LTE will be the next public safety network technology. So there then has to be the question, is LTE suitable for public safety? Well, of course, it has a lot of advanced communication features. It's a very fast, a very efficient network. But maybe the one thing lacking at the moment with LTE is a kind of a full support for voice communications. Now, you're aware, of course, of a thing called voice over LTE, okay, which is a 3GPP standard which shows us how we make phone calls through the network. But in fact, the way in which that network is designed, or the way that those services are defined within the system, means that we can use those basic principles to provide services which are more applicable to public safety communications. So, of course, large-scale group calls, push-to-talk, device-to-device if we need to do that, network resilience, mission-critical communications, and so on. So those capabilities have either been defined in the release in 3GPP Release 12, or are continuing to be defined in further releases. So we look towards Release 13. So there's still a little bit of work that needs to be done to bring LTE as a communication standard, completely up to the mark as far as public safety communications are concerned. So we'll just take a couple of those examples and say a few things about them. Group communications, I mean, that's pretty much fundamental to most public safety communications. And for LTE, the group communication service is really defined at two levels. There's what's being referred to as group communication system enablers, which is just really a series of architectures and protocols and mechanisms which allow us to make, shall we say, simple group communications. Now, the way in which the simple group communications is really being defined is perhaps more along a commercial basis than a public safety basis. But for Release 13, so as we go forward in the standardization process, we're going to use the basic architecture and services defined by the system enablers to define these mission-critical push-to-talk services. So public safety group communications require a greater degree of control and security when making those types of group calls. How do we define the groups? How do we control who has access to the group or who has control within the group? Those things need to be properly defined by the standards bodies. But by releasing it in two separate waves in this way, it's said to sort of allow for some degree of flexibility in deployment and maybe even a service differentiator, because not all so-called emergency services would necessarily require absolutely mission-critical group communications. So in line with the architecture of the network, we can either do group communications through a unicast method or using a multicasting broadcasting service, which is also defined for LTE. And I'll show you very briefly what that architecture looks like. In fact, here it is. Now, it's a rather kind of complicated looking picture of what the network is, but the little grey box on the at the bottom here is really the standard LTE network and can make use of unicast delivery. So if I'm going to make a group call between myself and 10 other users, for example, then what that network has to do is to really establish 10 completely separate voice bearers to the target users. Now that's a mechanism which could be done, today with the current networks, but it perhaps isn't the most efficient thing to do. So if we've got very large groups or mission critical groups, then unicast delivery perhaps isn't the most efficient way of doing it. So it's intended then that really what we will be using is at the top of the page here. So this top grey box that says MBMS delivery. So this is the multicasting, broadcasting, multimedia service delivery, and that requires some maybe additions to the networks. We couldn't guarantee that your current standard LTE network at the moment even supports these multicasting broadcasting functions, but they're really essential for group communications for public safety. So there's a couple of elements in here which are really going to be quite crucial, not least this group communication service application server, the little kind of orange box you can see off to the right hand side there. This is an essential component. I'll say a bit more about that in a moment or two. We've also got this MBMS gateway, and then there is a control entity, and I'll say a few words about each of those things. Clearly you can see if you're familiar with the LTE architecture, you see on this diagram a lot of new interfaces being defined. So we've got M1, M2, M3, and so on. There's many new interfaces in there, and each of those new interfaces may have on it a new protocol stack and a new set of processes defined for controlling access to and communicating within various groups. So it's difficult to say which is the most important component, but this is clearly an absolutely essential component as far as group communications are concerned. But the interesting thing about this is that it's a process or an entity which can be managed by an external third party. So this idea then that we might be sharing commercial LTE networks means that this box here could really be part of our public safety organization, and it would hook into, or it would communicate with, the third-party communication service provider. So in the UK, this would be EE. So this would be, if you like, an airwave server, if we can continue to use the airwave name, and that would be connecting to the EE network as far as the communication provider. But what this box does, it's based on IMS technology. Okay, so IMS, again, it's a very well-established technology in terms of mobile communications. And this particular application server really provides functions like group membership control, flow control. So when you hit the button to speak, who's actually in control of the communication flow. It defines security, so who's allowed to be a member of a specific group, or how to switch between groups, and so on. We can also hook onto the back of that dispatch-related functions, which is quite crucial for many public safety organizations. But this can be defined as a standalone function that is managed by that external third party, which I think makes it quite an interesting concept. We've got this is the multicasting broadcasting multimedia service gateway, which is a bit of a mouthful, MBMS gateway, and what that's really responsible for is really the sending of all of the IP packets. Now we're using an IP multicast service in here, so that gateway is essentially taking the packets, taking voice packets or media packets, for example, from a component in the network, and then deciding to which parts of which geographical domains within the network should we be delivering that information to. So it's essentially a user plane device. So packets will come in, packets will be copied and repeated to all of the relevant locations around the network, but we've also got some session control, some signaling, and so on associated with that. But that's also communicating with, or it's instructing another device here, which is this is the coordination or the control entity, which is actually in charge of the allocation of resources for the multicasting of the voice calls, the media sessions. It's described, as many of these functions are, as a logical function, so it's not necessarily a standalone function as it's being shown here, but may well in fact be part of a base station or an eNode B function. So its job really is to allocate the resources required for the communication, determine things like which modulation coding scheme should be used for communications within that base station, and such like. So there's going to be multiple functions required within that multicasting process, which will most likely needed to be added to the basic functionality that the commercial operator would have. Clearly, if we're going to build our own standalone network, then those functions will be the primary functions really of communication within the LTE organization. Now, another thing which is often seen as being really important is this idea of direct communication between parties. So when we think of mission critical communications, often that means that we need to be able to communicate even if there is no actual network connection. So of course the normal communication path for most communication entities is to direct the traffic via the core network, and the core network is in control of the routing and the switching of that communication path. But in public safety, there's plenty of occasions where a direct communication path is much more desirable. This is actually referred to as a proximity service, is the name given to it in LTE. Those of you familiar with TETRA, coming from a TETRA background, are probably more familiar with that in terms of direct mode. It is essentially the same thing, but we're referring to it here as a proximity service. So proximity services, or PROS, I'm not really sure how we're supposed to pronounce that, but PROS, it's a process really where the mobiles are able to discover or detect mobiles in the local vicinity and open up a communication path directly between them. So we don't necessarily need all of the core network and communication from the radio access network. It's possible to open up a direct communication path. One of the problems that has to be resolved, though, is how does any given mobile wishing to communicate, how does it know what other mobiles are in the local area, and how do we synchronize communications between them? And there's two different kinds of discovery. There's a direct discovery, whereby the mobiles will basically find each other without any direct intervention from the core network. But there's an EPC level discovery as well, where if the mobile is in direct communication contact with the network, then the network is able to provide information to the communicating device about the locality or the availability of mobiles in that area. Now, again, there are sort of two different styles of this, I suppose. There is a kind of commercial idea that we could share information, photographs and so on a more direct basis without using the network. But I think for public safety, there has to be a series of additional steps which define a proximity service for public safety, such as authorizing the devices to use public safety, or what groups should be defined for a more direct mode of communication in this way. One of the other benefits of using a proximity type service is the ability to use devices as a repeating function as well. So in this particular case, your UE1 establishes a direct communication or a proximity communication with UE2, and UE2 is effectively acting in this case as a repeater towards the network. Again, if you're coming from a TETRA background, that's a really familiar scenario in that UE2 may well be a vehicle-bound device and acting as a repeater towards the network. But whilst we might be familiar with these in services like TETRA and P25 and so on, these are services that have to be additionally defined for LTE. I mean, many of these services are already somewhat defined, shall we say, in the various releases that we have for LTE. So some of those services were being defined sort of back in release 10, release 11. But there's still quite a bit of work to do. Release 12, should we say, is pretty much completed now, but there's still a lot of work to be done. Enhancements to those proximity services, mission critical push to talk, and so on. These are the absolutely essential for public safety services that we'll have to have built into our LTE networks. So there's still a lot of work to do as far as using LTE as a public safety system. And it's interesting to see what different countries and different organizations are doing in terms of how do you bring those networks forward. Now, that's pretty much the end of our presentation. It's really only a 30-minute session that we have here, but just to remind you of who we are and what we do, again, here is our contact information at the bottom. So if you've got any email inquiries about training, there's a phone number and an email at the bottom there. But if you're interested in this topic, as you clearly are, then there is also, we have scheduled a 2-day training course for LTE in public safety, and that's scheduled to run 26th and 27th of May in Amsterdam. Okay, so you can go to our website and find out more information about that, or you can email or phone directly to find out more about what we'll be doing on that particular training course. Now, I'm just going to drag a couple of things in here. So if you want to download that presentation, there's a little document there that you can click and download. If you have any questions, we have a few minutes for questions, then you can use the little chat pod here to ask some more questions. And we would appreciate it as well as if you would give us a quick score, 1 out of 5 in that case. So thanks very much for attending this. I hope you found it useful. Please do download that document. We have also recorded this session as well. So our marketing director, Paul Waite, will likely be in touch with you and provide a link to that recording. So let me just take a few questions here. So KRN, whether mission critical voice capabilities well, that's a pretty good question. I mean, it's something we didn't really dwell on in this presentation about what frequency bands should be used. It seems sort of fairly clear. Well, in places like the States, for example, I mean, they've got a nationwide 700 megahertz is sort of been put aside for public safety. But if we are using the commercial operators, then of course the one thing we need to do is to make sure all of these services are available in those different frequency bands. So as you mentioned, the 2.6 gigahertz band. So that's something that's probably still needs to be resolved. What specific bands can be used for public safety communications, or whether those public safety organisations will come to the commercial organisation with their own set of spectrum bands. No, you've talked there about TEDS, the sort of enhanced data service for. Yeah, well, for sure, TETRA has some enhanced data services. In fact, I mean, the deployment of TETRA, when you start to look at what the TEDS service looks like, it's beginning to look very much like LTE. But perhaps maybe just the reworking of the existing TETRA network in terms of cost and benefit. I think certainly how it looks here in the UK is that it's seen that it's too expensive, too complicated to upgrade the existing network. So yeah, TEDS. I think we'll probably just we might write that one off for now and say that LTE is really what it's going to be for the next one. Yeah, and Paul, we appreciate your comment there. A bit too short. Next time a bit longer. Yeah, we're a bit limited in time with what we can do with these, but let me just see. Yeah, Mohammed, you've made some comments there about the spectrum, so region 1, 700 megahertz. Yeah, the ITU as well. We need to look towards the WRC, the World Radio Congresses, to see specifically what they might be doing in terms of spectrum reservation for public safety and communications. So yeah, thanks for your comments. Now, Paul, what would you say that has informed UK to switch from TETRA? I think probably, as I mentioned in the presentation there, just that the inability of TETRA to support advanced data services, and I think there's a greater demand from the blue light services, obviously the fire brigade and so on. There's now an increasing demand for these video type applications where you can do live streaming from an incident, maybe live streaming from from a police officer's uniform, that kind of thing. And we have those types of services already, but they tend to be applications that are completely separate to the TETRA system. There's one or two applications and devices out there that actually allow, it's almost like a dual mode device, something that, we hit the button, we use TETRA to use voice communications, but built into the device as well will be an LTE radio, which allows you to make use of some more advanced services through LTE. So, but I think in the long run, LTE has got to be the target for this. But as I mentioned as well, we need to sort out some of the issues regarding sort of voice type and voice-based communications. Yeah, Jim, I appreciate your comment as well. I did gloss over a little bit TETRA as the enhanced data. For sure, it does have that upgrade, but I think in overall performance terms, I think LTE probably still bests it a little bit. Richard, you're asking if I can indicate when Release 12, Release 13 will be released. I think Release 12 is by and large completed. Release 13, or at least some of the standard like Mission Critical Communications PTT, for example, is due for release this year, so 2016. I think the majority of the Release 13 specifications will likely be completed this year, but some of them may well drop into 2017. Do I have an indication when the first handsets and base stations will roll out? Sorry, Richard, absolutely no idea. No idea, because well, EE and Motorola, who are basically the providers of the network and the user services, they only really signed up to this. Certainly the Emergency Services Network, they only signed up to this, I think, in November, December last year. So we're still on a fairly short timescale from when those agreements were made. So we may have to kind of hang fire a little bit until we see more details on that. Right. Yeah, Paul again. Cellular operators want to avoid being sued. What's the state-of-the-art threshold regarding reliability? Well, there's another really good question, and probably one that doesn't have an absolute answer for the time being. Again, I'll just highlight the differences between the designing and building of a commercial network versus public safety. So clearly, in that agreement that we would see between between the public safety partners, they're going to have to enforce redundancy mechanisms. Because if you look at things like the airwave network, for example, I mean, there's virtually an entirely redundant network for that system. So even if one part of the network was taken out in its entirety, then we still have redundant communications. So, and that's something clearly at the moment the commercial Yeah, hi. Yeah, sorry, I lost my connection there, but I think I'm back on now. Um, yes, I can't remember which question I was answering there. I think you're all making some very interesting and useful comments there. I don't think we've got time to answer all of those, but I do welcome those. I'm going to review some of those comments later on. Maybe when we send you a follow-up email, maybe I'll try and get back to some of those questions and maybe just put together a short paragraph covering some of those. But yeah, I think if you look in South Korea, I think in Qatar, one or two other places, already there are some trials taking place with public safety systems using LTE. So yeah, Brian, sorry again, my connection just failed there. Yeah, so you're saying LTE is it not a proprietary implementation of the standard? Well, at the moment, yeah, I mean, Mohammed's come back there was saying no, it's based on 3GPP release 12. However, there are moving forward. Okay, my connection seems to be failing at the moment, so I think we'll probably leave it there. And again, appreciate all the questions and appreciate your attendance on this session. I will just leave you with. Just bear with me 1 second. I'll just leave you with the details of the course coming up towards the end of May and our contact details there. Right, so thanks very much. We'll see you on the next Telecoms Academy Insight webinar. So bye for now.